Good evening, everyone, and welcome to the 2025 AIP Careers in Quantum Science Careers Night. So, welcome. Thank you for coming. So, my name is Ryan, and I'm the president of the Physics Student Society here at the University of Melbourne. And so, just before we get into things, I'd just like to thank everyone who organised this. This is a big collaboration between so many different people. So we have the Australian Institute of Physics, RMIT Applied Quantum Technologies, and Infleqtion, and also the Physics Student Society. Yeah, so please, everyone, please a round of applause for them, for all the help. Thank you. And so before we get into things, I'd just like to acknowledge that we are on the lands of the Wurundjeri people. They have been the traditional custodians of this land for thousands of years, and they continue to be the first scientists and inventors. So I'd just like to pay my respects to their elders past, present, and emerging, and acknowledge that sovereignty was never ceded and never will be. All right. So to give a little bit of an outline for tonight, where we're going to start with some 5-minute presentations from the key supporters of this event. And then we'll move into more of a panel discussion where I've got the lovely panel here. Thank you so much for coming tonight. Sorry. And yeah, after that, we're going to do that for about 40 minutes, and then we'll have more of a chance for some free-form networking, and we'll have some food catered by the Atlantic group. And also there'll be some booths up there where you can chat to some of the people here tonight. Yeah, okay, so without further ado, I'd like to welcome Dr. Benham Tokaboni to the stage to give a presentation for Infleqtion. Thank you. Oh, I'll just stand up.
I can sit here. Hi everyone, thank you, thanks Ryan. My name is Benham and I am a quantum software engineer at Infleqtion. I'm just going to quickly talk about the Infleqtion company. So Infleqtion company has been around since 2007. Can you see that? Oh, there's nothing here.
There we go.
There we go, okay. Here it is. Yes, Infleqtion company is around since 2007. And it started at US, and nowadays has more than 200 people that. It has offices in UK and Australia, and footprint in Japan and International Space Station. The product that we have, it's a quantum technology company. The products are started with the quantum core, which is a prism to have atomic cloud in that, and all of our products based on that. We have tickers, which is the atomic clock, and we have a Skywire, which is a quantum radio frequency sensor, and also we have we are working toward quantum computer, neutral atom quantum computers. And that's it for me, and I'm a software engineer in that group. Thank you.
Thank you so much, Benham. Next up, we have Dr. Erin Grant from AIP, RMIT Applied Quantum Technologies. Thank you.
Hi. Yeah, I'm Erin. I am a postdoctoral researcher at RMIT, part of Racket. So I'm just going to give you a bit of an overview of the types of research that we do in Racket, and I guess give a bit of an advertisement to anyone who's looking at doing a master's or a PhD. We have a lot of projects that are across both experiment and theory, and we're always looking for students. So Racket is the RMIT Applied Quantum Technologies Centre, and we do research across sensing, navigation and timing, materials and manufacturing, computing and communications, and then quantum fundamentals. So that encompasses both experiment and theory, as I mentioned. These are the sort of main, more senior researchers that are part of Racket. I work closely with JP, David, Philip, and Blanca, and also Brant. So I'm within quantum sensing, so I know a lot about that type of research that's going on, less so, unfortunately, about the other areas, but I'm happy to direct you to some of the other people who do other types of research. So just to give you a bit of an overview of the type of things that we do in each of these areas. So as I said, I work in quantum sensing. In particular, I work with diamond, which you can see here, and other types of materials that house spin that we can utilize for sensing. But we do work with other things as well. Sort of this fiber technology is a large part of what we work with. And we have a lot of collaborations with companies as well. So these are some of the collaborations that we have. So we work closely with, for example, Quantum Brilliance. We have collaborations with Army, with Phaser. A lot of it is very diamond focused. We also do research in quantum computing. So that's largely probably theory, but also with looking at materials. These are kind of the areas that we look at across there as well. Again, we have a lot of collaborations with industry in this area. So these are some of the companies that we work with in that space. We have a lot of research in quantum materials, so improving the materials that we use for sensing or computing. So a lot of that is research on diamond materials, but there's a range of other examples of that. And finally, in quantum fundamentals. So we have a lot of researchers who do theory that not only helps us with our experimental design and understanding of what's going on, but also just from understanding the very basics of what happens at the quantum scale. And again, we have a few centres. So Combs is just started and they're building new labs. But we're also part of other centres as well. So yeah, if you're interested, I would encourage you to look at the website for Racket, where you can see more information about all of those areas. And yeah, reach out if you're interested. Thanks.
Thank you, Erin. And Dr. Andy Martin from RMIT, representing AIP.
Thank you. Yes, so my name's Andrew. I'm from the physics department at RMIT, but also for a few years I've been volunteering on the Victorian branch of the Australian Institute of Physics. And, you know, on behalf of the Australian Institute of Physics, we welcome you all here today. We have partnered with student societies to help run a careers night each year for many years now, and it's always kind of a highlight of the year. We also do a few other things through the year. We run public lectures, we run the odd lab tour, and a few other kind of activities like that. So I would suggest kind of looking out for some of the things the AIP does. If you are not a member, it's free for students to join. So join, get on our mailing list, and then you'll hear about things that are happening in the future. And if you do go on and have a career in physics, whether that's academic or whether that's out in industry, consider staying connected to the AIP, maybe even consider volunteering, because our branches and our committees are run just by volunteers. There's always some academics, but we always have people from industry. We have teachers, and we currently have synchrotron people at the moment on the committee, and we have our secretary is a crash scene investigator. So it's nice, actually. So one of the really nice things about the AIP is that you stay connected with the physics community, and you stay connected to physics people who may have gone off to do very different things in their careers. So I would suggest, look out and stay involved in the AIP in the future. And yeah, that's all I really wanted to say. So I'll pass back to Ryan, and who can start the panel discussion.
Thank you, Andrew. And also thank you to the Australian Institute of Physics. Without your support of events like this, clubs couldn't run things on this scale. So a huge thank you on behalf of the Physics Student Society, and I'm sure many other students' clubs that you help out. All right, so to move on to the panel, we'll start with some more general pre-selected questions, and then we'll open it up to the audience for some questions there. So yeah, just to start us off, would everyone please just give a brief introduction, where you went to uni and what you did after that, and how you got to where you are now? Yeah, if you want to just move down the line, perhaps.
Hello, everyone. Does it work? Okay. My name's Xing. So I'm a new, senior lecturer at RMIT working on quantum information technology. So I did my undergrad at the University of Sydney, and then I pursued a PhD, also at USyd. I went to the UK to do a postdoc for 3 and a bit years, and then I came back to Australia on a Sydney Quantum Academy fellowship, and I got a DECRA fellowship, and now I am at RMIT.
Hi, it's a pleasure to be here. My name is Lucas Hackel. I'm a senior lecturer jointly between physics and mathematics here at the University of Melbourne. You can probably hear that I'm German originally, so I did my undergraduate in Germany, then moved to Canada for a master's in theoretical physics. Then I took a year off and taught mathematics at an institute in Senegal, in Africa. And then I wanted to do fundamental theory and pursued a PhD in quantum gravity in a gravity group in the US, but was very much drawn towards exploring entanglement and kind of fundamental concepts of quantum information in space-time, and pursued that after my PhD by doing a postdoc in Munich, then Copenhagen, and then I moved to Melbourne and kind of went through different stages here, first as an academic visitor, then as a postdoc, fixed-term lecturer, and now I'm here for good, working in more the foundational quantum information aspect in the context of quantum technology. Yeah.
So I introduced myself as before. So yes, I'm Behnam, and I did my PhD at University of Queensland. My research was on two-direction atom interferometry and also silicon devices. It was on quantum technology, but it wasn't on quantum computing. Then I did a postdoc at Griffith University, which I worked on the open quantum systems and the quantum control. And in my postdoc, I would become more informed about the quantum computing and be familiar with that. And then I moved to CSIRO, quantum team, and I worked on the quantum algorithms for the quantum computing. And after 1.5 years in CSIRO, I joined the Infleqtion as a quantum software engineer.
Wonderful. So my name is Kevin. I'm a senior metrology engineer at Quantum Brilliance, a startup company that looks at room temperature quantum computing. My history, though, I started doing a PhD at La Trobe University in surface terminations of diamond. It's slow doing research when you're looking at in UHV. So I moved on to material science and looked at renewable energies. So I did 8 years of postdocs, and then sort of found that I was ready to move on to something else. Did another postdoc at RMIT alongside Aaron for a little while towards the end, looking at quantum sensing, and then that opened up some doorways into quantum computing, into where I am now.
Yeah, I'm Erin. So I did my PhD at the University of Melbourne, graduated officially last year, in the middle of last year. I worked at CSIRO in their new quantum biotechnology group for a year, and then I joined RMIT at the beginning of this year. Yeah.
Great. Well, it's lovely to meet you all. Could I ask if there's like a quantum technology or phenomenon that most interests you, what would that be? Like, wave functions like tunneling.
I'll answer first. My research is focused at using quantum sensing for biological applications. And when I did my undergrad, I was unsure about whether to go down the biology route or the physics route. I got very lucky and did an internship with a biologist who introduced me to my master's supervisor, which I ended up doing in physics. All that is to say that I am particularly interested in the way that quantum states and systems can be used to learn about our environment at a very high level of precision and sensitivity. So I think the physics that underlies quantum systems is very interesting, but I'm particularly interested in how we can use that for applications. Yeah.
I guess I'll follow on. I have a soft spot for tunneling, actually, now that you mention it. So in my undergrad, I did a project with Chris Pakes looking at the surface of diamonds, where we were able to image the surface at an atomic scale using a scanning tunneling microscope. And that was very exciting to actually see individual atoms. It was impressive. It's what got me into stay into physics and go into a PhD.
I have two different answers to that. They are kind of related. One is in open quantum systems. I'm really interested in open systems in general, because whatever we learn from the Newtonian mechanics to quantum Schrödinger's equation, you have closed system and everything you do very nice. But in reality, everything is open. You have connection, you have friction, you have interaction with the environment, and that always was fascinating for me, that you cannot distinguish. A closed system is an approximation always in reality when you are doing it. And the other thing is kind of related is I'm interested in quantum sensing, although I'm doing quantum computation a lot. But quantum sensing, I'm really interested because, again, with that idea of the open quantum system, you have a quantum system that interacting with an environment, and then you learn more about that environment. That's kind of fascinating for me.
Yeah, I already mentioned that I'm interested in entanglement, and I think entanglement is really a fundamental concept that is extremely exciting, and it's really at the core of what quantum theory or quantum technology is about, in the sense that what sets a quantum theory apart from classical theory is that you can have statistical correlations that you cannot explain classically, Bell's inequality. I mean, you may say, oh, probability is what is happening in quantum theory, but you can have classical probabilistic theories, and so superposition alone and probability uncertainty is something that doesn't set alone your theory apart from like quantum theory from classical theory. But entanglement, to have type of correlations, for example, testing through Bell's inequality, that really shows the statistics is fundamentally different to what you can have classically, is very exciting. And you can use it as a resource for quantum teleportation, quantum computing, super dense coding. But it also reveals something about the structure of states. Bell's inequality, you can only violate them with entangled states, as mentioned, but also fundamental questions such as quantum correlations across space-time have the potential to reveal something about what our world looks like on these small scales. So entanglement is probably the phenomena I'm most excited about.
I'm going to be boring and also say entanglement, because just fundamentally we have no classical intuition on why it works. So for those of you who don't know what entanglement is correlation between two or more particles which are beyond, they share correlations beyond that is classically available, right? So the collapse of the wave function, as far as we know, is instantaneous. It doesn't matter how far the particles are separated apart. If you measured one, you know you've affected the other. Yeah, that's fascinating. And also, if you talk about it from the technological perspective, it's a resource for computation, for sensing and communication. And basically, you can do things with it that classical system just cannot do.
Thank you. It's so many interesting things in quantum science, and I'm sure we could talk for hours about all But to move on to something else, what would a typical day in your life look like in your career or field? Yeah.
Okay, sure. I'm a theorist, so basically I spent my day in front of the computer doing maths or coding. So that may sound boring to some people, but it's not the individual tasks which are interesting, it's the big picture. So I'm usually solving an equation for this particular problem which fits into this context. And you get to obsess over into as much detail as you want into a particular problem, and I find it enjoyable.
Yeah, I'm also a theorist, mathematical theorist, or physicist. So, I mean, there's lots of stuff of calculating and kind of just sitting there and thinking about stuff. But I think the exciting part is really engaging and discussing with students, discussing with colleagues in front of the blackboard or via Zoom internationally, and figuring out something together. Yeah. And of course also teaching, interacting with students, presenting something, explaining something, and seeing like the person in front of you kind of having a kind of epiphany in their mind, understanding something, and often yourself understanding something or seeing something through another perspective. But in terms of the everyday and now as an academic at the university, it also includes a lot of administrative and bureaucratic tasks, replying to emails, figuring out some invoices, responding to special consideration requests, scheduling exams and things like that. And I started to find that actually also quite exciting. Like essentially, in some sense, you need to understand doing research in physics is already so exciting, adventurous, one could say. To have this dry bureaucracy can really kind of calm you down and help to relax and enjoy the combination of both. So it's not as bad as some people may make it sound.
Thank you. Yeah, I'm also a theorist, but I'm in industry now, and don't think that in industry there's no admin. There's more admin, I would say, in industry, and I don't enjoy that. But about the day-to-day activity, it really changes the day-to-day. One thing that I really liked about the research, and either in industry or science, is that it is not, there's no routine. It's day-to-day, it changes. One day I read more, one day I write more, one day I quote more, so it's very different. One day I just spend hours in front of the whiteboard looking at an equation or a sketch and do nothing, just look at it because I don't know what to do. Yeah, and yeah, there are lots of collaboration as well. The collaboration is really important, and you need to, if you want to be a scientist, you need to talk to people and see different ideas, different perspectives.
Right, so my typical day is not really a typical day because we're setting up our laboratory. So for the last couple of months, we've just been ordering equipment, organizing shipments coming in, invoices constantly. So when we get past that, though, my typical day will look like interfacing a lot with potential customers, identifying their material needs, and trying to help them to develop their quantum technologies, to help them reach their dreams, and in doing so, reach our dreams. So I guess that's the typical day that I look forward to. I'm in metrology, so material analysis will also be a key part of it. But I'm hoping to pass that on to someone junior who can do the continuous routine measurements. But if you're hearing Marcus, please find someone else.
I think being a scientist is the best job. I love it so much. Being an experimentalist is similar to what everyone else has said, but I guess on top of that, there's a lot of time in the lab. So as people have already mentioned, there's no like typical day, I guess. It's very, very varied. So I really like it because you get to use every type of skill, I guess. Like there's a lot of writing, there's a lot of communication, talking to people, problem solving, also physically doing things, making things work. I work with optics a lot because we use lasers for our experiments, and I like to think of it as adult Legos. So there's a lot of putting things together, aligning systems to make them work. And then I work in wet labs as well because I create samples to measure. So I work with biologists. I use cells sometimes. So yeah, it's very, very varied, and that's why I love it so much.
Great. So some of you really love paperwork and bureaucracy. But like, how did you discover that that was your passion? I suppose I should say not the paperwork, the other career, the other, yeah.
I guess I'll start again. Actually, I was driven by fear, a fear of an intellectual cage. So I did a year in industry during my undergrad in a lab, of which I won't name. But it was so boring and mind-numbing. I almost had a midlife crisis. Maybe I had a midlife crisis. And I decided I need to do physics and not set lab work. Yeah, so I discovered what real life work was like, and I'm like, I don't want to do this anymore.
Yeah, I still don't really know what it's like to do like real life industry work. So I'm missing that perspective a little bit because I didn't know quite what I wanted to do after high school and looked into various different directions, and I was good in physics and math, but then also kind of considered lots of other areas what I could study. But then I was at some party, and a friend of mine, she had already started university in like some early program, mathematics and physics, and told me about complex numbers. And I was like, wow, I mean, I haven't done that in high school, and if I don't do a course with like math and physics, then I may end up like not knowing how that works with complex numbers and these type of more advanced abstract concepts. So I decided that I should do something like physics, math to definitely get that covered. No? And from there, I just enjoyed what I was doing and ended up here. Yeah.
I was always good in math as well, so and I was really interested in science since high school. But whenever there was any kind of science class from biology, chemistry, I was really passionate to understand what's happening. But I wanted to understand the world, the nature, in the deep level. So I was thinking that okay, biology is chemistry with extra, and chemistry is physics. So I'm going to do physics. And my wife sometimes asks, why you like mathematics a lot, why didn't you do math? I said, math is hard, physics is easier. I'm doing physics, yeah.
My answer is a bit more alphabetical, actually. So I went through my subjects when I was in year 10 to decide what I wanted to do for the rest of my life, as I'm sure many of you have. And I crossed through the arts, and I didn't want to do any of those. And I got through the humanities, and I didn't want to do any of those. And all that was left was sciences, so I signed up for those. But I think what draws me to science is the problem solving. I love going in every day, having a new problem, sometimes the same problem, and solving it, bashing your head against it for a long time. But that's also exciting, because you do get those eureka moments, and they're great, they're amazing. But I like problem solving, and I like the variety that you get in science. Every day is different. Sometimes you're in the lab, and that can be a little bit mind-numbing at times, but it does give you a bit of a break from those times when it's full go, and you're going to conference, and you're meeting people, and you're on a panel, and then you're flying out to Canberra or something the next day. So having that variety is really good, it's really healthy, and it's really exciting.
I initially studied science because of the challenge a little bit. I was very undecided. I like a lot of different things. So when I decided what I was going to study at uni, I wanted to do fine arts. I also wanted to do science. And my mum was like, well, what are you going to get a job in at the end? So I studied science. I still love art though. When I had to choose, because I went to Melbourne University, you have to choose your major, and I started out studying everything, and I didn't know which type of science I wanted to do. And I thought, what is the thing that I definitely can't teach myself? And it was physics. So I thought I should do that if I want to learn any physics, and then fell in love with it. And when I found out in my master's that I could still study biology and physics at the same time, I was kind of sold. But I think I really decided that I wanted to be a scientist when I finished studying and didn't have to do exams anymore. And I was just in the lab and found that actually being a scientist uses a lot of the skills that I'm most good at but hadn't gotten to use, which is actually writing and talking to people. And they're actually a huge part of science, which I didn't know, but also problem solving, I guess. So it just happened to be the thing that like used all the skills that I really love the most and value the most. Yeah.
Thank you. And let's just hypothetically say you were talking to someone who was interested in your field, wanted to go into that, like me. And what advice would you give to them? And are there any like skills you think are really important that you need to be in your field? Would you like to start, Erin?
Yeah, sure. So this was a skill I didn't have when I started, which was coding. I was terrified of coding actually in undergrad. I didn't have any experience in it. I thought I would be terrible at it, so I just didn't even think about learning. But it's not that scary, and there's so many resources online, and it is a huge part of the job. Like, I think no matter what kind of science you do, you're going to have to write code to analyze things or create models. So I think getting yourself acquainted with that as soon as possible is probably a good thing, especially if you think that it's a bit scary. And the easiest way to do that is to try and actually make something to do something. It's not, I didn't find it very easy to learn if it was all purely theoretical. Yeah.
I would also agree coding is super important and it's super fun and there's so much you can do with it nowadays. So I would encourage everyone who wanted to have a career in physics to get into coding. But because you already covered coding, I think I'd also talk about communication. Communication is very important. When I was starting my PhD, my writing was atrocious. My PhD supervisor once told me that my writing makes him feel physically sick. Which looking back, I can understand and I appreciate how resilient he was. So practicing your writing is a really important skill, and also practicing your public speaking because you don't know when opportunities are going to arise. And networking is super important, so being able to have conversations with people, just anyone, and just connect with people will really help to boost your network and boost your career opportunities.
Yeah, thank you. That was good. So you talked about coding and networking and communication, and I do agree on all of that. And so I'm trying to find another thing to add. One thing that I would generally would say that mathematics is important. You need to have a fundamental understanding of mathematics for physics. Also, the other thing that I was going to say that don't try to find a problem that matches your skill. Find a problem that you are interested in, and then for each problem there it does need its own skills. Then you're going to learn those skills. Whatever skills you have for the next problem, you may need to learn a new skill.
In mathematical physics, you don't necessarily need to know how to code. It can be helpful, but it's not strictly required. I would say in general, of course you need some level of being good at math. But you don't need to be amazing or like completely outstanding. Like it's an interesting misconception, I think, that a good researcher in theoretical physics, mathematical physics, must be like a genius in like abstract math, for example. That is just not true. Like being a researcher and making meaningful contribution to the field are much more than just being able to solve complicated problems. Because as a researcher, you don't just solve problems. You come up with problems, you choose what is worth to work on, you collaborate with other people, you identify whom you like to collaborate on problems that are worth to be solved or to be worked on. And in many instances, it might be more impactful to have a very good idea or creative new approach and apply that to a relatively simple system that probably a good PhD student even could solve, than just solving a very, very hard problem that then doesn't spread and kind of inspire as much follow-up research. So, and I think there is a diversity of different approaches and skills that can work. I mean, you can really enjoy teaching and interacting with students. I mean, this is helpful, but there are some colleagues that don't enjoy that part as much, and that's okay. And similarly, within the different research areas, there are people who prefer to kind of work on hard problems. There are others who are like much more about conceptual ideas and not so much about like very high technical rigor and so on. So my advice for the area that I'm working in is really be inspired kind of by the questions that you find interesting and the people that you enjoy working with and collaborating, which is also, I mean, feeds in the communication part. It's rarely something that you do alone. It's possible, but it's much more enjoyable and also more impactful if you collaborate.
I'm going to elaborate on that a little bit more. So, yes, well, I'm not sure innovation is a skill, but it's like extremely important. So as you go through your career stage, different skill sets become relevant. So when you're an undergrad, you're doing exams, so your answer, so you know the skill set is what is the right answer. But when you get to a PhD, the relevant skill is kind of what is the right question to ask. And then by the time you get to your first postdoc, it's like, how do I make this impactful? And how do you identify the important questions to answer? And then something that goes along with is your writing and communication. If you don't write something down, all of your collaborators are extremely busy. If you had a meeting and you don't write things down, that just disappears. So yes, communication and innovation.
In a similar vein, what do you think like the skill deficits, or like are there any skills that are in demand in your field that aren't or are lacking at all? Sorry.
I think I would kind of piggyback on what has already been said about communication. Like, I think it's something that takes a lot of practice, actually, and especially presenting. It's hard, and it's actually a skill that takes a lot of practice. And I think that's something that if your supervisors are really like invested in your career, they'll help you develop, because it's not something, I don't think it's something that you should be expected to have necessarily when you first start your academic journey, but I think it's something to prioritize or think about, because it is really, really important.
So something I've noticed is project managing is often something that we're not taught as scientists, but it's something that's very critical. And often we're very good at managing one or two projects with very limited resources, with very limited oversight. But when it starts to get to larger number of projects, we tend to fall down in a bit of a heap sometimes because we can get a little bit overwhelmed and we don't have the right skills. We haven't been taught how to manage that. So I think that's something that would be beneficial to help with training the next level of scientists, you guys.
I was going to say something similar about the project management, and the thing that I found, at least in the industry research, in the quantum technology industry, there are lots of people like me coming from the academia, and the mindset is very academic to do the research and maybe toward the publication, finding new findings and new problem solving, but industry wants solid projects and do something that you can work on that as a product at the end. So project management and being organized about the output, something is lacking, I think, in the new kind of startups companies. And not lacking, but it's not weak. It's not strong enough, it's weak.
I would try to answer essentially with two answers, two perspectives that I think play a role and that I'm dealing with, like in particular the first one at the moment. And that is, as you kind of progress in your career at a university, at some point you essentially manage a research group. And of course, if the research group is more focusing on a specific one project or a couple of projects that are very well defined, I agree, project management is very important. Another aspect, and I would say the more theoretical, less defined research that has like lots of open questions that I'm dealing with, but I also think in other areas of experimental research that plays a role. You have the well-defined projects that you need to manage and pursue, but you also want to have a research group that is kind of a hub of innovation and good ideas. You want to have somehow social cohesion, that people want to be happy to be part of the group, interact with each other. You don't want to have just individual students or postdocs working on their own project. You want that there is some exchange, that people know what other people are doing, that they can communicate with each other and create this positive, inspiring vibe where everybody is excited to be part of. And that is not something that you can just define and tell people, okay, that's how you need to do it. You need to kind of create this atmosphere, and I'm trying different things how to approaching this. But it's again something that wasn't taught in university or postdoc career, how to create this environment. And the second part, that's more a little bit of one potential career advice if you want to go for the academic career, and that is you want that people somehow can remember you and associate you with something that you stand for. And this can be something very concrete, like this is the quantum sensing guy from UniMelb doing this exciting thing. It can also be more exotic and say, oh, this is kind of this person who is all over the place, from theoretical stuff to industry collaborations on something exciting. But I would say a lot of people that I see having succeeded in an academic career were able to kind of frame, not necessarily very early on, but definitely at some point in their career, what they stand for. And that's maybe just food for thought to consider if you're going for the academic career.
I think at the beginning of your PhD, something that Australian universities don't teach very well is like the emotional resilience to be told by science that you suck at it. Because like if you get to 4th year and you're thinking about signing up for a PhD, your marks are probably very high and you probably think that you're very good at it, right? But then you start your project and the first thing, it doesn't work, and then it doesn't work for 2 years. And then a lot of people get depressed and stressed, very stressed. So I think that's something that the community hasn't really dealt with very well. Like, so almost like emotional coaching slash being therapists to your PhD students.
Well, thank you. That's really insightful. So with 2025 being the year of quantum and there being such a focus on quantum science in Australia at the moment, where do you think in the next 10 years the field will develop? what technologies do you think will become available, and how will things change for your career?
I think if I knew that answer, I would already be doing it. But I expect that like a lot of the quantum error correction things that are happening will turn into engineering. I think dark matter discovery is a big one. Yeah, so turning a lot of the current open problems into engineered system, I think.
Yeah, I mean, in terms of quantum technology, I also think that I mean the big challenge is to get to fault tolerance in some way and have quantum devices that are not as noisy, and leaving the area of NISQ, of noisy intermediate scale quantum devices. Something that was already claimed to be reached if you frame it the correct way, is to reach somehow utility, no? Like that quantum devices or quantum computing devices can be used for some tasks, not necessarily be faster than classical computing, but still useful to be utilized. The other part, I don't feel like from that perspective, as a researcher in the field, and in particular in my case more in the kind of foundational area, I don't think I'm a particularly good investor that, for example, would know exactly what to bet on. Neither what specific technology in terms of like platform, nor company. So yeah, let's see.
Yeah, about the quantum technology, there are three kind of categories. There's quantum communication, quantum sensing, quantum computing. I work on both quantum sensing and computing. I'm not in communication. What I can say is that, so I'm fascinated by both, and I'm pretty sure they both have a kind of a good future. But if I want to bet for the next 10 years, I bet on the quantum sensing. Maybe quantum computing will catch up as well, but we don't know if in 10 years we can have a big enough fault-tolerant quantum computers. Yes, we would have quantum fault-tolerant quantum computers in 10 years, but is it big enough, scaled big enough for the sort of problems that we want to solve and beat classical computers? I'm not sure. But for the sensing part of the quantum technology, I would say we will have many different quantum sensors in different areas.
Yeah, I kind of agree. I think quantum's kind of going to start becoming a bit ubiquitous, and we'll just have devices that'll just have quantum technologies in them. We'll be driving an EV car that has a quantum sensor in it to tell us how much range we've got left on the battery. I disagree, though. I think quantum computing is going to reach
10 years.
10 years, yeah. I work for a quantum computing company, and that's within our timeline. But
Conflict of interest.
So we're using quantum accelerators that will be coupled with GPUs and CPUs. So not trying to replace, but trying to enhance by coupling in with them. And I think that's where quantum computing will be at in 10 years.
10 years is a long time, but also not a long time. So in terms of research, I think that time can go past pretty quickly. But what I would like to see, I think, is there are a lot of quantum sensing startup companies that are quite early in their lifetime. And I would love to see them become viable, profit-earning companies that are actually, like Kevin was saying, just answering questions and being used. In particular, I really would love to see quantum sensing being used to answer questions in biology, being used by biologists rather than physicists. So things that are actually usable by people that don't have a background in optics, for example. I think that's where my hopes lie, I guess.
And most importantly, are any of you hiring right now? I can give you my resume if you like.
I might.
I suppose a more useful question is, who is your field looking to hire at the moment?
As I mentioned at the beginning, Racket has a lot of positions for students. So if you're thinking about a PhD, please get in contact with me. I could pass you on to the relevant person if it's in any of those kind of areas. From the sensing perspective, we have quite a lot of projects at the moment that we would love people to work on. So yeah, if you're looking for a PhD, come and find me.
We have some vacancies at the moment that are posted on our website, so Quantum Brilliance. But in particular, we're looking for a materials engineer, so someone who can do CVD growth of diamond, preferably at high quality.
Infleqtion Australia is a small team at the moment. We are looking for grow fast. We don't have any position available right now, but we are looking to add positions very soon. I myself, as a lead of the software team, looking forward to a few software person. I mean, quantum software person probably is theoretical people, but we haven't advertised that yet, so it will come soon.
We got a project recently approved called Without Space-Time, Quantum Without Space-Time, which is across fundamental theory and quantum technology. So Quantinum, for example, as a quantum company, is also involved in this project. It's an international consortium led in Madrid and Rome and Vienna, but Melbourne is a node of this, and in that context we'll be hiring at least one postdoc sometime next year across relativistic quantum information to quantum information and foundations of quantum theory. But more broadly, there are certainly also PhD positions available through the Unimelb program. And of course, that's just my group. There are lots of other groups at Unimelb and in general in Melbourne with a number of universities. So one additional comment I just want to make, what in my opinion makes quantum technology a really exciting avenue for somebody starting out a PhD, and that is previously, in particular in theoretical physics, the options that you had were either you do your PhD and apply what you learned directly by continuing the academic track record, or at some point after your PhD or your postdoc, you say, oh, I want to go to industry. And then there are these transferable skills that you're good at solving problems, and then you solve problems that are not really related to physics, like hedge funds or consulting and so on, which is cool. But now in quantum technology, you can pursue your PhD and then have the option to pursue an academic career or an industry career, or even switch between the two, as some of my colleagues have. And I think that is a really exciting opportunity, that you know what you learn in your PhD is also directly and not just abstractly transferable to some extent into the real world.
So I'm just telling what I see that people are hiring. So I'm not sure if you're aware, but like PsiQuantum, quantum startup, just got awarded about $947 million in Queensland. I think they're hiring. I know a couple of other startup companies. Xanadu, who's associated with RMIT, is hiring. Quantum Control, there's a base in Sydney. They're hiring. A couple of places, and also there are usually many postdocs. Basically, if you're willing to move overseas, there are plenty of postdocs available.
Excellent, thank you. We've got a couple minutes left, so why don't we open it up to some questions from the audience? Does anyone have any questions? Quite a few people.
Thank you. Hello. Hey. Thank you for being here. You've given a lot of information to us, so thank you for that. The question I have is, how important is a postdoc right now in the quantum science? Because I'm doing my master's currently, and I do want to go into the industrial section, industrial quantum computing in the future. But I'm not looking for a postdoc currently. So, like, how important is to do a PhD?
If you want to do a postdoc, then you have to have a PhD by definition.
Oh, sorry, I'm a bit confused. Okay, so any of the, because I don't want to study quantum computing after doing my master's. So does that like make a difference if I get into industry? Do you think?
Perhaps I can answer. So I only got into quantum sensing about 2 years ago, and that's because JP, someone that from RMIT, the racket, he wanted to do imaging of photovoltaics with NV sensors in diamond. So I had diamond background, and I had 8 years of postdoc experience imaging and just characterizing photovoltaics. So then I was able to get the jump into quantum sensing and then eventually into this, working at Quantum Brilliance as metrology. So having the relevant experience, I think, is important. I don't think necessarily having a postdoc experience is important though. So if your PhD is aligned well, then I think there's good opportunities there. And I think there's more opportunities often if you're an early graduate as opposed to when you've done a couple of years of postdoc, and you're sort of in your mid-career, because then that's a different regime and there's fewer opportunities often.
I have seen a perspective though, like, so this is another startup company which is not exactly quantum, but the feedback I got from that team was that they were trying to hire undergraduates, so just graduates with a degree into doing that kind of work, but they were finding that the people with a PhD do a lot better compared to someone who's just had an undergrad, just because you have the problem-solving skills. And if you're thinking about working in a science startup company, or just any company that works that's based on science, you will be competing against other people who have PhDs.
There are 2 engineers working on the quantum RF sensing, and none of them has PhD, but they both have more than 3 or 4 years experience after their bachelor. So the experience is very important, but it doesn't mean that experience should be a PhD. And it depends on the job and the requirement of the company. Not all.
Are there any other questions? Raj?
Yeah, I just wanted to talk about just your answer right now. Do you think what you said about having the PhD or doing the postdoc and the people who've done the PhD being more useful, do you think that's because of some sort of like survivorship bias in the pool of people, or is it because by definition the people who've done the PhD, they're more qualified than the people who just have a bachelor's degree or a master's? So do you think it's more useful to not do the PhD, just go straight into industry?
My opinion is that what a startup company and technology needs, they want to spend money on people who has the experience. You need to have that experience somehow. It can be with the PhD or with working somewhere else that is useful. So my catch is that so look at it like that there's an advertisement for a job about some sort of a sensing device or something like that, and you can apply. Everyone can apply, but you are competing with people that have a PhD or have experience for a couple of years, more than 3 years on that topic. So that's about the competition between these people.
I think I'd like to just add to that in Australia, I don't think there's an easy way to get the experience that you need to be hired at one of these companies without at least a master's degree. an undergraduate won't teach you the knowledge that you need, unfortunately. It's quite specific knowledge, whether that be the theory or experimental experience. If you're coming at it from the perspective of being an engineer, I think that might be different. I don't really know about the qualifications of an engineer, but I think you probably have more hands-on experience just from an undergrad maybe. But yeah, I think you would need at least a master's degree with a project to have had the hands-on experience and technical knowledge that you would need. Because so if you think about a very large company where you would come in and do a graduate role, those companies have graduate programs and they're willing to invest time and money into training you into the very specific role that you're going to have at that company. Whereas if you're going into a startup or a small kind of quantum company, they don't have those programs yet. You know, maybe in 10 years they will, but they don't now. So they want to hire people who can just do the job immediately. Like they don't want to spend 2 years training you in the specific skills that you need. Yeah, unfortunately, I think that's just kind of what the landscape is like at the moment, just because it is so new. Yeah.
Thanks. So what do you think are some of the key things that people look for in applicants to some of your positions?
That's a very broad question.
I guess in terms of like quality, like, I don't know, experience, grades, things like that.
Are we talking about a PhD student, a postdoc?
I mean, yeah, I guess like both academic and industry. So like, depending on like, you know, what your role is, what you think would be looked for in like an incoming applicant.
If I were looking for a PhD student, so I've seen two categories of students at the undergrad level. One category, which I think none of you fall in, is that you hear the quantum and you get seasick. Anyway, and then the other category is like, okay, this is cool, this is exciting, I want to get into it. So that's an attitude that you know, you can't really teach. What else? Curiosity is very important, I think. So you can teach someone technical skills, but you can't teach curiosity. So because if you're curious, then you're driven. So I would like to see someone who's not driven by the abstract idea of, oh, I need a PhD, I need to I need to succeed but rather I really love science. Yeah.
One thing I would like to add, that we don't look at the candidate that has the old skill that we want, because we are doing, again, research development style, so there are lots of new things, and we don't expect that we find a person who knows what we need to. So, but we were looking for people who can learn those things fast. So it's really good if you can show that you can learn fast. It's really hard things to show, I know.
I think from the perspective of starting a PhD, I think something that's really important for you and for the supervisor is to have a meeting. A PhD is long and hard, so the relationship that you have with your supervisor is very, very important, and I think they're going to be looking at you to see if it's the right fit, to see if you can work together in what is a very collaborative relationship. But you should also be thinking about that as well. It's going to be 4 years of your life as well. So you want to be making sure that your supervisor is someone that you will work well with. So I think a lot of supervisors, when they're interviewing people, have that in the back of their mind. So like has already been mentioned, are you curious? Do you seem like someone who is willing to learn and someone that they can work with? So we look at grades and things as well, but it's actually a lot about, is this the right fit for both people?
Sorry, I like to add, do not lie about something that you're not interested in doing. Because the thing, like the science is really hard. If you don't like answering that question, do not do it because you won't get anywhere. I've had students sign up and they didn't get anywhere.
I can mention also perspective on postdocs. There are different types of postdocs. No? There are postdocs where you are hired for a specific project. You need to have exactly those skills, and you pursue and work on the specific projects. And then there are postdocs where you may have like one project with your supervisor, but you're also expected to just be independent and self-driven. And the more like theory postdocs that, for example, we have in our project, but that I'm also used to more on the like theoretical physics side, are much more of the second type, which means just being able to have specific skills for specific projects is not enough, and often not even the most important part. But if you apply for such a position out of your PhD, you need to show or be able to show that you have some vision and some level of creativity of ideas that you are able to pursue on your own as well, maybe even already with collaborators that you have. And that is, of course, then also a crucial requirement if you want to take the next step in an academic career, like becoming a permanent academic or group leader, because there you will not just work on a project anymore, you will come up with the projects and lead them.
Thank you, everyone, for the really valuable questions. Could everyone please give a huge thank you to our panelists? Thank you so much for your time and your expertise. Kieran, would you like to hand out some tokens to thank you? All right, so we'll now be moving to a more free-form networking opportunity. So we'll have some booths over there, and we'll have some food. You don't? Soon? Do you need me to fill in time? Okay. Yeah, we'll have drinks. You can enjoy some drinks, yeah.